Good morning, good evening. I am Jared McCormick, and I am here to talk to you about a code review. And that's what we're going to be doing here this afternoon. I will be discussing the code as it relates to the three computer science categories of software engineering and design, algorithms, and data structures and databases. In this review, I will be analyzing my code for weaknesses, limitations, and vulnerabilities. I will be looking at this through 5 different lenses or ideals. I'm going to be trying to show how I'm going to or have employed strategies for building collaborative environments, the design and development, and the delivering of professional quality oral and written visual communication, which is this video. I'm going to show you how my code is going to meet the intent of the design and the implementation of data structures and algorithms. I'm going to demonstrate how we are going to use well-founded and innovative techniques and tools to solve a problem. And then I'm also going to address some of the security concerns. If we look at the code over here on the left side of the screen, you'll see that this is some code that I developed when I was a freshman at SNHU. And when we run the code, what we're going to see is it's going to ask us to enter a year between 2005 and 2016. And we're going to pick 2005. What happens is it's going to ask us, hey, how do you want to sort the movies that come after that? Do you want it to be a year, director, movie title, or press Q for quit? Well, we can do that, and it's a pretty simple output, and it starts 2005 and goes to the end. And then we can press D for director, we can press T for title, and it organizes them by year and title respectively, and then we can quit, and it's going to press any key to continue, and we're back to our regular code. Utilizing over here on the right side of the screen is our review checklist for our code review. We're going to be looking at our structure, the documentation, the variables, arithmetic, operations, loops and branches, and defensive programming. Starting with the structure of this program is very rudimentary. This, again, as I said, this is from 2018 when I was just starting out as a computer science student for SNHU. And what you'll see is the statement up here at the top is this was the goal of the project, was to build a dictionary containing the specified movie collection. The dictionary is sorted with the year being the key and the title and director being the value, so it's a key value pair. And then we were going to prompt the user, we're going to ask them to sort the movies in some sort of way. Now going back over to our checklist, does the code completely and correctly implement the design? Yes, it does. It implements the design that was intended for the project. Does the code conform to any pertinent coding standards? There were no real coding standards for this class other than we had to use this sort of key value pair to set up our dictionary, and the rest of it was really up to us to figure out. The code is well structured and it is very consistent in style and consistently formatted. Everything here is set up the way that we were sort of taught at the time. We would implement our larger stuff at the top, so like our dictionary, we would start our variables, and then we would start following all the way through the main program. One of the things that is real noticeable when you look at this is it's all one file. We'll address that a little bit later. Are there any uncalled or unneeded procedures or any unreachable code? No, every single piece of this code is reachable. It all executes. Can any code be replaced by calls to external reusable components or library functions? We'll come back to that. We'll come back to that one. That's one of our areas for improvement that we're going to talk about here at the end. Is the storage use efficient? Yes, it's a dictionary in Python. It's as structurally efficient as you can be with a dictionary in Python. There is no real room for improvement there unless you wanted to start modifying the dictionary or adding new inputs into the dictionary, in which case you most likely wouldn't use a dictionary. You would use something like the note data structure for Python. There are no magic numbers that contain strings, and the modules are not excessively complex. They are all set up into a really straightforward way to sort a list of movies. Documentation. Is the code clearly and adequately documented with an easy to maintain commenting style? No. The code has a little introduction at the top, and then it talks about what each piece of the code is going to be doing, and then when we get to the bottom here, I don't know exactly what was happening. I feel like I was most likely trying to understand exactly what I was doing as a new person, newer to the use of coding to solve a problem. And what I did was I just hard coded everything, saying this does this does this, make sure how to do X, Y, Z, listing everything out. One of the things that I'll tell you, they are consistent throughout the code in that it's all over commented, but that's another thing that we're going to address when we get towards the end. The variables are properly defined with clear and meaningful names. They're using the traditional Pythonic style of name underscore definition, and then they are all assigned and they all have a similar, there's no type consistency that you really need to worry about in Python in this particular scenario. And there are no redundant or unused variables. There are no arithmetic operations that take place within this code, so there's no real need to deep dive into that particular portion of the code review. The loops and branches is another story entirely. While this is one method that you could use to get through all of the sorting of movies, this could have been done in a number of different ways. The way that it is implemented here, there's nothing that is improperly nested. Everything makes sense. There was no testing that was done at this point in my degree. We hadn't learned about implementing unit tests, searching for edge cases, etc., etc. So there's no implementation of that with here. So there's no case where there's code testing that was left in. There's nothing that is going to come up if you run the code that's like, oh no, this was supposed to be from a test. Yes, every case statement does have a default, and the default would be to ask the user for the input, and if it doesn't receive input, it's just going to hold there. If they press Q, it's going to quit. It'll just run its way through the code. There's no real way to validate that. The loop termination, there are no real loops other than the for loops, and they all have a clear exit, and the exit would be check to see what letter was pressed. If an invalid input was input is implemented, what happens is this. It's gonna just ask you for the operation again. It's just going to run itself back through there. There are no indexes. The statements are enclosed, cannot be placed outside of loops. And does the code in the loop maintaining the index variable? There is no index variable. Let's see. There are no real complicated indexes or pointers here. Let's see. Imported data and inline arguments are tested for validity and completeness, and that doesn't apply here. Are the output variables assigned? Not applicable. Are the corrected data operations on in each statement? Yes. Is it in-memory allocation is not something that we learned at this point in the degree plan. There are no errors that are stated. That would be something to add. It wouldn't be too hard. Are files checked for existence before attempting to access them? That's not something that this program does. And are files and devices left in the correct state upon program termination? That's not something that's applicable here. That's something more for like a state machine or a embedded device. When we now circle back to some of the things that we're looking to do with this code, the first and foremost thing that we're looking to do with this code is we're going to be trying to make sure that we hit those 5 objectives for the course. And I'm going to talk a little bit about how I plan on modifying this code as an idea to showcase my growth as a developer. In 2018, this code for me was the pinnacle of my coding career. It was the most complex thing that I had ever written, and it really took me through the ringer. I struggled a lot with determining the layout. I over-commented everything. There was a lot of things that I would like to do differently, and there's a lot of ideas that we can take, or I can take through this experience that I have with this code and this degree to showcase the 5 outcomes that we're looking for in this course. The first outcome that we're looking for reads, to employ strategies for building collaborative environments that enable diverse audiences to support organizational decision making in the field of computer science. By modifying this code in the way that I'm looking at, I'm going to create code that is malleable when it comes to showcasing the implementation of the problem-solving methodology that computer science teaches us. And I'm going to show innovation through unique implementation of different software development techniques to showcase my ability to solve problems or create solutions. Our second thing that we're going to be looking at is the design, develop, and deliver professional quality oral, written, and visual communication that are coherent, technically sound, and appropriately adapted to the specific audiences and context. That's what this video is more about. We are, through this video, showing you how we can explain comfortably in a relaxed manner, in a semi-formal manner, how we are able to navigate ourselves through code that is developed so that you can clearly understand what is going on in the code and clearly see how the solution is broadly applicable to the majority of the code that is written. Design and evaluate computing solutions that solve a given problem using algorithmic principles and computer science practices and standards appropriate to its solution, while managing the trade-offs involved in design choices. Now we're going to jump into what my plans are for this particular course outcome, along with how I plan on modifying the existing code to operate completely different from the way that it currently does. What I plan on doing is taking this code as inspiration is to develop a graphical user interface that has a login for users and their different tiers of users, and I'm going to link that graphical user interface with a backend database, and in that database I am going to store a large amount of data, and in that I'm going to allow the user to see the return time using maybe different search algorithms. One of the main algorithms that I'm going to implement is the binary search tree. I picked this because I wanted to show my understanding of the binary search tree, and also it's just another one of those data structures and algorithm that I really struggled with, much like this code when was the zenith of what I understood at the time. The binary search tree was something that really took me through the ringer, and I felt like I really needed to step up the way that I was pursuing understanding how information was stored and sorted and returned to a user. And I feel like that is going to allow me to hit multiple different of these course outcomes at the same time, while also building something that's fun, engaging, and can showcase the variety and the implementation of different problem solving techniques to get through a given scenario. The next thing that we're going to do is we're going to demonstrate an ability to use well-founded innovative techniques, skills, and tools in computing practices for the purpose of implementing computer solutions that deliver value and accomplish industry-specific goals. Software engineering, design, and database is the category that falls into. For me, I wanted to create my own database. I don't know if I'm going to pull all the information off of the internet yet, or what database I'm going to use for the backend. I'm thinking something similar to MongoDB, and that's something that we've used in the course, and it would be cool to go back over that again. The use of the graphical user interface, along with the added features of the ability to show how there are different return times based off the complexity of the algorithm that's used, and having that something that the user can directly see, I really feel shows how we can show the difference in algorithms instead of just looking at the mathematical equations. Is this O log of n, etc., etc. And the last thing that we're looking at and that we have is the develop a security mindset that anticipates adversarial exploits in software architecture and designs to expose potential vulnerabilities, mitigate design flaws, and ensure privacy and enhance security of data and resources. The way that I'm going to be tackling that in this new code that I'm developing is by creating a username and login. So you're going to have to, the user is going to have to log into the software or the program in order to access the database, and some people, based off of their different permissions, are going to have the ability to read only the database. They can read and write to the database, and then other users will have full create, update, read, and delete permissions within the database. That is my overall plan and my code review. Thank you for your time, and have a wonderful evening.